The lesson topic for this video is reference angles in special right triangles. Okay, so we're going to connect a couple of things that we've been working on, one being the special right triangles we reviewed, and the other is the reference angles we've been using for a while now. So, the first thing we're going to do is we're going to draw the angle that's given in standard position. Okay. So we know that 315 degrees. So we're going to start with our vertex at the origin and our initial side on the x-axis. We know that this is 90 degrees, 180, 270, 360. 315 is directly between the 270 and 360. So we will draw that angle right about there. Now it says find the measure of the reference angle, that's theta prime, we know about that. So theta prime is found with the terminal side of the original angle and the nearest portion of the x-axis. So our reference angle is that same angle there, which is theta prime. Okay. Now we can find theta prime because we know that the initial angle theta is 315, again this right here, 315. And so therefore, in order to get from 315, this location here, to 360, we know that is a difference between 360 and 315. So 360 minus 315 is 45. So we have found that theta prime is 45 degrees. Now this is where we see a connection between our reference angle work and our special right triangles. Because if I drew the triangle now in this diagram, now we don't have a point right here like we're used to draw up from the terminal side to the x-axis, but we can draw it anywhere we choose. So right here is fine. If we draw that right triangle, what kind of right triangle is it? Well, if we know this is 90 and we know this is 45, then the only remaining number of degrees that we could put here is 45. Which means we have a 45, 45, 90 special right triangle. So what we're going to do is we are going to draw and label, we did the drawing of the right triangle. Now we're going to label the sides of our special right triangle. Remember, we have to use negatives if we're moving left or down. Alright, so we're going to name those sides. And we know in a 45, 45, 90 triangle, across from the two 45 degree angles is a side length of 1. And -1 here, okay? Because again, we're going right here, so it's 1, and we know this is a length of 1, but since we're moving down, we're going to write -1, and that's something that people will miss sometimes. So 1, -1, and we know that the hypotenuse in a 45, 45, 90 triangle is the square root of 2. And at this point, that is all we are going to do with these, is we're going to find out which special right triangle it is, and we are going to label the sides. And we'll add to that more in the next lesson. Let's try one more. Okay, so we have a -120 degree angle. First thing we need to do is draw our original angle in standard position. There's our initial side, and -120 means that we're going to go clockwise instead of counterclockwise. We're going to go past the 90 to 120, which is 30 degrees beyond this. So maybe right around there. Alright, there is theta, -120 degrees. Alright, so now we need to find the measure of our reference angle, theta prime. Well, the reference angle, as we know, is created by the terminal side of the original angle and the nearest portion of the x-axis. So here is theta prime. Alright, so here we go. We have to find the measure of that. Again, if our initial angle is here, original angle is here, and we need to rotate further to get to 180, so technically -180, but we're going from -120 to -180, we are traveling 60 degrees in this arc here. So theta prime is 60 degrees. Okay, so if that's 60 degrees, obviously we know that this is going to be one of our special right triangles. Now I'm going to kind of extend this ray a little further so I can draw a right triangle that's a little easier to work with here. So here's my right angle. And we have our right angle, which is 90. We have theta prime, which is 60, which means this angle down here must be 30 degrees. So we have a 30, 60, 90 triangle, and we are going to label the sides. And again, remembering our negatives. So across from the 30-degree angle in a 30, 60, 90 triangle, across from the 30 is 1, but we need to remember that it's -1 because we're going left. So -1. Across from the right angle, so the hypotenuse is 2, and that's not going to ever be negative. And lastly, across from our 60-degree angle is √3, and we are going down, so that needs to be this negative square root of 3. Again, negative square root of 3. All right, so we will practice this in class, but we're just creating those special right triangles and labeling the sides, paying very close attention to those negatives.